The Three Gorges Dam is the most powerful hydroelectric dam in the world. It can produce up to 112 terawatt-hours of electricity annually, which is enough to power Iceland, Ireland, Denmark, Slovenia, and the entire Hawaiian island group combined for a full year, while still having some electricity to spare. By harnessing the power of the mighty Yangtze River, the Three Gorges Dam effectively became the biggest producer of electricity in history, and thus a critical point in Chinese infrastructure. However, this modern marvel of engineering had to jump through a lot of hoops to get where it is today. Engineers had to find a way to move boats through the dam. Millions of people had to be displaced, and one controversy followed the other through the years, which almost put a complete stop to the project. Nevertheless, the dam stands firm today, after an entire century of scandal-ridden lobbying, planning, designing, and building. In this video, we'll analyze the brilliant engineering of the Three Gorges Dam, see exactly how it works, find out why it took so long for the Chinese to build it, and give a final answer to the most important question: was it worth it? Imagine this. It's the first half of the 20th century. You and your colleagues are the leaders of the national government of China, one of the world's most populous countries, with around 250 million residents, second only to India. You have to satisfy the basic needs for all these people, which, of course, includes electricity. At the same time, you have to do it in a sustainable way. Your country was built in the valley of the Yangtze River, which just so happens to be the longest river in Asia by a wide margin, and the third longest river in the world, behind the Nile and the Amazon. Luckily for you, Yangtze has a massive elevation drop, which is extremely important and useful for hydropower stations. On top of that, the valley itself floods during the rain season. So, you get an idea. Why don't we build a massive hydroelectric dam that will simultaneously produce an ungodly amount of electricity for our people and control flooding? This is exactly what the Chinese did. The story starts with Sun Yat-sen, who is a very important figure in modern Chinese history. Known as the father of the nation and the forerunner of the revolution, Yat-sen hypothesized that it was possible to build a dam which could generate 22 gigawatts of electricity. He was limited by the technology of his time, and he didn't know that the dam would, in 100 years, produce 5,000 times that much. But he had the right idea. The actual plans to build the dam were developed in 1932, but the project was abandoned when Japan occupied China during the Second World War. Then, as soon as the Second World War ended, which resulted in China's liberation, the Chinese Civil War kicked off and lasted until 1949. The United States taught more than 50 Chinese engineers everything they knew about dam building. After all, the Panama Canal project, one of the world's most important engineering feats, was very similar to the Three Gorges Dam in vessel lifting aspects. However, this wouldn't help the Chinese immediately, as the dam plans wouldn't get approved for almost 40 years. The Communist Revolution happened. Then economic problems occurred. Then a massive Yangtze River flood happened, killing more than 30,000 and displacing more than 19 million people. Throughout all of these events, Mao Zedong always wanted to build the dam, but never seemed to find a way to do it. He became so obsessed with the dam that he wrote a poem about it, called Swimming, in which he speaks about the plans to build a great dam, which will control the floods and, to quote the chairman himself, hold back Wushan's clouds and rain. The plans for the dam would be proposed in the early 80s, 60 years after the initial idea for a dam, and 50 years after the first concrete plant. The dam was approved in 1992, construction started in 1994, and the Three Gorges Dam became fully operational in 2012, 3 years behind schedule. The dam itself is 1.4 miles long and rises a whopping 600 feet above sea level. The spillway in the walls releases more than 4 million cubic feet of water per second. For comparison, the Grand Coulee Dam, which is the biggest hydroelectric power producer in the United States, releases about 1 million cubic feet of water per second, while the Baihetan Dam, the second largest dam in the world, also located in China, releases about 1.5 million cubic feet of water per second. All of this to say that no dam in the world comes even close to the Three Gorges Dam. To fully utilize the immense power of water in the area, the Three Gorges Dam uses 34 generators. 32 of those generators have a capacity of 700 megawatts, while the 2 power plant generators have a capacity of 50 megawatts. Each generator weighs about 6,000 metric tons, meaning that the generators alone weigh more than 200,000 tons, which is close to the weight of the Wonder of the Seas, the biggest cruise ship in service. Now, you might be thinking that these size and weight numbers don't really tell us a lot about how the dam works, and you'd be right. But it's important to understand the sheer size of this project to fully appreciate the precision of the design. The hydraulic heads of the generators are absolutely massive, coming in at 264 feet in length. And since the general rule in engineering is that bigger heads are better than smaller heads because they need less water to reach full power, this means that they were fully optimized for the dam's size. At the time of building the dam, the designers used the biggest Francis turbines in the world, with a diameter of 34 feet. They also used the biggest stator in the world, which is about 10 feet tall, with a diameter of about 69 feet, all amounting to an incredible efficiency of 94%. It was reported that the dam once reached an efficiency of 96.5%, which is incredible for a dam of that size. So, how does this work in practice? Firstly, copious amounts of water drop from the Yangtze River. Remember how I earlier said that the river has incredible drops, which is very useful for dams? Well, Chinese engineers utilized the Yangtze's drops brilliantly. The water is held in an incredible 31.9 acre-foot reservoir with a catchment area of 390,000 square miles, which is almost exactly the size of Egypt. It is then released into a water intake system of downward pipes called penstocks. The penstocks are obviously under immense pressure, so they had to be partially buried into the dam itself to ensure that they don't malfunction. Penstocks direct the water and focus its power onto the turbines. The massive Francis turbines that we talked about earlier then start turning by the raw power of 4 million cubic feet of water hitting them each second. The turbine has a shaft which is connected to a rotor. The rotor is stacked with magnetic steel laminations, which are called field poles. When the rotor rotates, the 80 poles move past the conductors that are mounted on the stator. As the name implies, the stator is static, and it does not rotate. Faraday's principle says that you can cause electrical flow by moving a magnet past a conductor. Well, if you have a lot of big and mechanically perfected magnets next to a lot of mechanically perfected conductors, you'll create a lot of electrical flow. As the rotors rotate, they produce electricity at a stunning rate of about 500 billion watt-hours per day, which is enough to power the White House for about 600 years. The electricity is distributed through transmission lines with a voltage of 500 kilovolts, which are some of the most efficient lines available today. Those lines then provide electricity to the people who need it. In the meantime, water moves through the dam and it's released into the river, where it continues to flow normally. It's not released quickly though, because that would cause a flood. The way the dam generates power, however, isn't the only impressive thing about it. The most impressive aspect of this massive project is that it does all that with minimal disturbance to river traffic. Now you know how the dam works and why it was needed. And the next logical question is, how did they even build this behemoth of a structure in the first place? Installing the generators was, quite frankly, the easy part of the Three Gorges Dam project. Earthquake and sedimentation assessments first had to be conducted to determine if the dam could even be built. The area was known for its seismic activity, and needless to say, the government didn't want to build a dam only to see it collapse a few years later. After several assessments, seismologists concluded that it's unlikely for an earthquake stronger than magnitude 6 to ever hit the area, and the water in the reservoir would be enough to dissipate the energy and protect the dam. The dam, including the copious amounts of water, is simply too large to be affected by earthquakes of that size. This was later proven to be true, as more than 3,000 earthquakes were recorded in the area since the early 2000s, and none have affected the dam whatsoever. Sedimentation was another major concern. Not only can it affect the river flow, and thus cause minor flooding downstream, it can also affect the production of electricity and flood control systems within the dam. To deal with sedimentation, engineers built 23 low-level openings in the reservoir to keep the water clear. It's assumed that reservoir capacity will still be at about 90% after 100 years of operation, which is great for the dam, but it doesn't prevent downstream issues, which we'll talk about later. Once risk assessments were completed, the building could finally start. The building was divided into 3 phases, with the first 2 phases taking part long before the generators ever came into play. The plan was for the first phase to focus on river closure, the second phase to ensure water shortage, build ship locks and install the first generators, while the third phase would see the completion of all construction, install the remaining generators, and finish the dam completely. Although construction formally started on December 14, 1994, it actually started in 1993, when a few construction teams started preparing the humongous construction site. When actual construction started in 1994, the majority of work was earth moving. The river's flow had to be obstructed to allow the pouring of cement. The workers accomplished that with cofferdams. The cofferdams were essentially 260 feet deep holes, which would later be filled with cement. A problem with pouring cement near bodies of water is that water seeps through the ground and reaches structures from below, destroying them. To prevent this from happening, the engineers dug numerous holes below the cofferdams, with a total length of more than 60 miles. They filled these holes with pressurized grout to create a so-called grout curtain, which protects the concrete from ever being reached by seeping water. In 1997, the river was officially diverted from the cofferdams, and the real cement pouring could start. The second phase saw more building of the massive concrete wall on the left side of the bank, and the installation of the first generators. The workers were set on an unforgiving 4-year schedule, which was unbelievably ambitious. And not to stray away from the plans, more than 25,000 workers were hired just for the cement pouring jobs. They poured cement at the rate of about 14 million cubic feet a month. For comparison, it's estimated that about 1.7 million cubic feet of concrete was used to build the Empire State Building. This required logistics beyond anything the human race has ever accomplished before. First of all, to ensure unobstructed workflow, the Chinese government built a highway to the dam. The only purpose of the highway was to transport workers and work materials. And this was no ordinary highway either. It's more than 17 miles long, almost half of which consists of bridges and tunnels. One of those bridges is almost 3,000 feet long, making it the longest bridge in mainland China, not including Hong Kong. Secondly, they supplied the workers with 5 fast-rotating conveyors and 6 of the biggest construction cranes ever used. These cranes were specially designed with jacking systems that could raise and lower said conveyors. By using this system, the workers managed to pour the cement at a quick pace, but this wasn't the end of their troubles. The thing about concrete is, it releases a lot of heat as it sets and dries. If concrete gets too hot, it can create cracks in the structure, and since digging the entire dam up and starting all over again wasn't really an option, this was a mistake the engineers could not afford. To keep the concrete at a temperature of about 45 degrees, they built a low-temperature concrete mixing facility, the largest of its kind in the world, so the concrete was already pretty cool when it arrived at the site. They added cold water, sheets of ice, granite, and Class 1 fly ash, which is a very specific crushed coal-based residue, to the concrete mix to keep it cool. When it was finally poured, they used ground cooling fans to keep the concrete cool. Around 85% of all concrete measured less than 45 degrees, so it's safe to say those methods were a success. At the end of the second phase, the dam's wall reached almost 300 feet, 14 generators were installed, and the southern ship lock was completed. For engineers to have constant access to the turbines, special maintenance tunnels were built, allowing them to inspect the generators. Water was then released into the reservoir, although not completely, because the reservoir was only half built. Days after filling it up, 80 cracks appeared in the front-facing wall of the dam. This was a major concern. If the wall broke down, a massive amount of held-back water would be released, causing massive flooding downstream and without a doubt costing lives. The cracks, however, didn't spread and they were fixed. No such incident was ever recorded again. After that crack scare, the final phase ensued, during which the dam wall was finally finished. The third phase was almost identical to the second phase, but on the right bank of the Yangtze. Concrete was poured into the cofferdams, and the remaining generators were installed. At the same time, all the 14 generators on the left side of the bank started producing electricity, even though that wasn't originally planned, meaning that the dam started producing electricity a year ahead of schedule. Once the right side of the dam was finished, the workers had to remove the cofferdams. You know how they did that? With dynamite. More than 200 tons of dynamite to be precise. After literally blowing the cofferdams up, the construction of the final, top portion of the wall could begin, which would mark the end of the Three Gorges Dam construction project. It's a common misconception that you can see the Great Wall of China from space with the naked eye. This is completely untrue, and until recently, it was often said that no man-made construction could be seen from space. Well, as of 2006, that's untrue, as NASA reported that astronauts can actually see the Three Gorges Dam from outer space without the use of a telescope. On May 20, 2006, the dam was finally completed. For the next 3 years, generators would be put into operation and get tested collectively and individually. The dam would raise water levels in the reservoir, and on September 15, 2009, all the originally planned roles of the dam were tested and greenlit. It could now produce electricity, control flooding, and provide irrigation to the local agricultural fields. To ensure undisturbed river traffic, a ship elevator was built and sprung into action in 2016, on top of the already existing locks. Unlike the Panama Canal water locks, which use water itself to raise and lower vessels, this elevator uses traditional helical gear systems and weights to lift and lower ships. It is the second largest ship lift in the world, with a vertical lift of 371 feet, while the remaining two of the world's 3 largest lifts, with a lift of 259 and 417 feet respectively, are also in China. In terms of carrying capacity, it is the most powerful lift in the world, capable of lifting and lowering absolutely massive vessels, including some tankers and container ships, with a massive gap between it and the second most powerful lift in the world, which can lift 2/3 of the weight. It takes between 30 and 40 minutes for a ship to be lifted or lowered through the nearly 40-story tall building, although the record lift was clocked in at 8 minutes in 2016. About 18 vessels can be lifted or lowered in a day. The speed of the lift depends on the weight of the vessel, the weather, and other factors. Since water levels are often disturbed by the dam itself, building this lift was a big challenge for the German engineers that designed it. The lift has to function even if the water levels vary by 39 feet at the bottom and 98 feet at the top. Aside from the lift, the Three Gorges Dam has 2 ship locks, which I've mentioned previously. Each lock has 5 stages or staircases, if you will, and these massive systems can lift and lower even heavier vessels in about 4 hours. These locks lift and lower ships by loading separate compartments with water, essentially using the water as a platform for lifting and lowering vessels. In 2022, vessels amounting to a staggering 160 tons in weight passed through the locks, reducing shipping costs by 25%. One lock is reserved for upstream traffic, while the other is only used for downstream traffic, which makes the system incredibly efficient. The Three Gorges Dam is the heaviest concrete structure in the world, at least for now, and the concrete alone weighs an unfathomable 144 billion pounds. And that doesn't account for the massive weight of the water or the generators, which, as said before, weigh 6,000 tons each. This means that the entire dam weighs more than 270,000 wonder-of-the-sea cruisers and more than 11,000 Giza pyramids. As you might expect, building such a massive structure has a massive impact on the environment and nearby residential areas, which caused a lot of controversy in China. First of all, the dam was on a vulnerable piece of land when it comes to sedimentation, as mentioned before. Some scientists hypothesize that the riverbanks located downstream from the dam will become more vulnerable to flooding over time because of the lack of sedimentation there. Since the dam collects so much sediment by slowing the stream down, less sediment arrives at Shanghai, which is only 990 miles downstream from the dam. This could make Shanghai more prone to flooding, according to some scientists. Secondly, the dam is inadvertently causing landslides. There were 97 landslides in the first 4 months of 2010 alone, caused by the erosion of rising water in the reservoir. Keep in mind that the dam wasn't fully functional before 2012, so it's safe to assume that the erosion only got worse with the completion of the dam. Thirdly, the dam has definitely negatively impacted both flora and fauna in the area. The immediate area around the Three Gorges is home to 57 endangered species, and the area already went through massive deforestation between the 1950s and the new millennia, with the proportionate forested area remaining at 10% in 2002, which is, needless to say, catastrophic. Building a dam on top of the already existing damage had a terrible effect on wildlife. Aquatic animals, including the now extinct Chinese river dolphin and a lot of fish species, suffered the most because they completely rely on the Yangtze to survive. Fish can get sucked into the dam's penstocks and die, and if that doesn't happen, the dam messes with the water flow and temperature, which is enough to displace and starve thousands of species. Some Chinese scholars even believe that the dam itself is guilty of the extinction of the Chinese river dolphin. Either way, The Yangtze is home to more than 360 fish species, which are key players in the ecosystem, with 27% of endangered freshwater fish species calling the mighty river their home. This has, of course, negatively impacted plants, birds, mammals, reptiles, and all other animals that live there. It's important to mention that the dam itself caused a lot of earthquakes. Since the dam itself is a gravity dam, it is so heavy and so well protected by water that it'd take a massive earthquake to damage it. However, the dam itself caused thousands of earthquakes, say Chinese scientists, by creating a massive water reservoir that generates a lot of pressure in pore spaces and rock crevices at lower depths of an area that is already known for its seismic activity. Although no earthquake-related damage was documented on the dam to date, seismologists warn that the dam could possibly cause an earthquake so powerful it could damage the dam. In 2013, a 5.1 magnitude earthquake rocked the immediate area around the dam, and it didn't affect the dam at all. Finally, more than 1 million people had to be displaced to build the dam in the first place. The Chinese government compensated the people for the move, but it has impacted the older generations negatively, and living conditions deteriorated for the people who stayed in nearby cities. However, not everything is doom and gloom with the Three Gorges Dam, and it would be unfair not to credit it for its life-saving qualities. It's not only the largest power producer in the world, but it's also crucial in flood prevention. The reservoir holds 5.3 cubic miles of water, which reduces the frequency of downstream flooding to once every 100 years. For reference, before the dam was built, major floods occurred once every 10 years. To prevent flooding, the dam releases the water from the reservoir on a yearly basis, between December and March, which is the dry season in China. The flow rate of the river downstream thus increases, improving shipping conditions and irrigation for agricultural fields. At the same time, upstream water levels drop by about 100 feet, providing reservoir space for the next rain season. The dam has already prevented several major floods. For example, the South China floods in 2010 took more than 400 lives in other areas, but the Three Gorges Dam successfully held the water back, preventing significant damage and loss of life. The Three Gorges Dam is arguably the most impressive feat of modern engineering. It is not only the heaviest man-made structure in the world, but it's also a crucial part of China's flood prevention infrastructure and the world's greatest electricity producer. Although it came at a significant cost for local wildlife, and it may have future consequences that we're unaware of, the dam's building was absolutely necessary. Would it shock you to hear that despite the incredible power numbers the dam puts out, it only produces between 1 and 2% of China's annual electricity consumption? This tells you just how much electricity China needs, proving that a dam of this size is truly essential to the people. Would it shock you to hear that more than 5 million people in China died in recent floods? Would it shock you to hear that that number only accounts for the floods that happened in the past 150 years, not including the floods before that? When you take that into account, you realize that the Three Gorges Dam wasn't a choice. It was the thing that made, and is still making the difference between human lives and what would have certainly been a darker present and future.